Hi again, this is Fernando from Untitled Project. Welcome to my channel. Today I want to give you another matrix equation, and I have chosen it very carefully because it contains a very specific situation. I mean, we won't be able to solve matrix X using the previous techniques that I showed you in the previous videos. Look, let's read together the statement and you will see what I'm talking about.
Untitled Project.
Given matrices A and B, there you can see that they are two very simple square matrices. Calculate matrix X in the following expression. Let's write it together. Matrix X multiplying matrix A must be equal to matrix B multiplying X, where A equals 3, 1, -2, 0, and matrix B equals 2, -1, 1, 0. Okay? Well, look at this equation carefully. You can see that in both sides we can find matrix X. In these two terms we can find matrix X. So why don't we move this term to the left in order to put them together? X multiplying A minus B multiplying X equals 0, or rather the order 2 null matrix. So now it's time to consider if we must take X common factor to the left or to the right. And as you can see, matrix X is on the left side here, and in this other term is on the right side. So I'm afraid that we cannot take matrix X common factor. This is the situation that I wanted to give you, as matrix X is here on the left side and here on the right side. We cannot take it common factor neither to the left nor to the right. Okay? So what are we going to do? Well, we are going to create a template for matrix X. As these are order 2 matrices, our matrix must be A, B, C, D, order 2 also. And we are going to put it there in both sides. We will multiply both sides of our equation and we will equate every position. Let's do it. Matrix X, A, B, C, D, multiplying matrix A, 3, 1, -2, 0, must be equal to matrix B, 2, -1, 1, 0, multiplying matrix X again, A, B, C, D. I consider that you have already mastered matrix multiplication, so let's go ahead. The result of multiplying two order 2 matrices will be another order 2 matrix. And let's do it together. Position 1, 1, row 1, column 1, 3A minus 2B, 3A minus 2B. Now position 1, 2, row 1, column 2, A times 1, A, and 0, A. Now position 2, 1, row 1, row 2, column 1, 3C minus 2D, 3C minus 2D. And finally, position 2, 2, row 2, column 2, that is C plus 0, C. Got it? Now we are multiplying on the right side, and the result of multiplying these two order 2 matrices will be another order 2 matrix. And let's do it together. Position 1, 1, row 1, column 1, 2A minus C, 2A minus C. Position 1, 2, row 1, column 2, 2B minus D, 2B minus D. Position 2, 1, row 2, column 1, A plus 0, A. And finally, position 2, 2. Row 2, column 2. B plus 0. B. That's it. Now, you know that in order for two matrices to be equal, we must equate every positions, that is, position 1, 1 on both sides. 3a minus 2b must be equal to 2a minus c. Now, positions 1, 2. A must be equal to 2b minus d. Now, position 2, 1. 3c minus 2d must be equal to a. And finally, c equals b. And now we have a four unknowns system, and we are going to solve it. This will be the solution of our equation. This is a very typical situation in mathematics, so how are we going to proceed? Let's round the simplest expression that you can see here. I guess you are looking at this expression. Let's round it off. And now we are using this information for the three other equations. I mean, where we will find a variable c, we are going to put b instead, okay? Let's do it. 3a minus 2b equals 2a minus c, or better, b. Second equation, a equals 2b minus d. And third equation, 3c, or better, 3b, minus 2 times d equals a. And now it's time to clean it up and go on. Let's clean together equation number 1. Well, we can put variables a on the same side. 3a minus 2a, that is a, equals negative b plus 2b, negative b plus 2b equals b. Now let's clean the second equation, and I'm afraid that there is nothing to do. A equals 2b minus d. And let's clean the third equation, but I'm afraid that there is nothing to do also. 3b minus 2d equals a. And now it's time to proceed as previously. Let's look for the simplest expression you can see here, and I guess we are going to choose the first equation. And we are using this information for the other two equations. Let's write a, or rather b, must be equal to 2b minus d. 2b minus d. And 3b minus 2d, 3b minus 2d equal to a, or rather b. And now let's clean these two equations. Well, I can see that here you can find negative d. Why don't we fly it to the left? D equals 2b minus b. 2b minus b, that is b. And here, let's do 3b minus b, that is 2b, equals negative 2d. Let's fly it to the right, and we will have 2d at the right, 2d. And you can see that both equations give us the same result, b equals d. I'm going to round it here. What is this result giving us? Well, the template for our matrix X is A, B, C, D. And you can see that mathematics is telling us that position A must be equal to position B. Position B must be equal to position D, and position C must be equal to position B, which means that the 4 positions must be equal. In order for not to give any privilege to any of these 4 letters, let's put the solution this way. Matrix X must be, let's think on any other letter, typical Greek letter, for example, lambda, and let's put it in the 4th positions. And let's add 4 lambda belonging to real numbers. And that's it. Well, knowing how to solve matrix equation is something very important, because when you are solving a matrix equation, you have to use every elementary operations. On this occasion, I wanted to give you another matrix equation that we couldn't solve it using the previous techniques, but we had to use a template. Don't forget what we've done, and see you next time. Bye! And now, watch a theory video if you think you've gotten lost in some aspects, or skip to the next exercise to continue climbing. And as always, like, turn on notifications and comment. See you soon!